Now we're going to talk about the hexadecimal number system. Now, hexadecimal system, we don't use in IPv4, but we use it in IPv6. Now, we haven't talked about IP addresses at that level too much, but IPv6 was created because IPv4 was running out of physical space as far as numbers that could be assigned to devices. So now you've got an IPv6 system, which now I can't worry about octets and I can't worry about binary because I don't have enough combinations. And because if I did binary, then the address would be too long, that they switched to having IPv6 represented in hexadecimal. Now, don't get nervous about hexadecimal. Basically, what's hexadecimal is basically just combinations of working in base 16. So you got the first 9 digits, 0 to 9, and then to get the other 16 values, you now add the letters A, B, C, D, E, and F. And each one of those has a binary relationship. The same with binary, or same with your decimal, if you want to think about it that way. It still has the same value. It still has positional value, but now it has A through F added to get you from 10 digits to 16 digits. So you want to make sure you understand the differences between decimal, the binary configuration, and what are the hexadecimal values. So 10 equals A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. Now, just know that it's used for basically two things. It's used for the IPv6, and when we start looking at MAC addresses, you'll also see hex used in MAC addresses, which just gives them a larger range also. It does tell you that in an IPv6, instead of having dotted decimal notation, what IPv6 does is separate things by colons. So you've got a single, what they call a hextet instead of an octet, which had 8 bits. You got a hextet, which means I'm covering 16 bits or 4 hexadecimal digits, and then each value in a hextet is a hex digit. So even though I'm not sure we need to cover all that right now, but just give you a rough idea what an IPv6 address is. So it just says, hey, there are 0 to 6, 0 to FFFF range within a particular hextet, because it's 16 binary digits, 8 or 4 hexadecimal digits, and each one of the hex digits can have a range between 0 and 4 ones. Now, in an IPv6 address, this is where I'm not sure they should have introduced this, but just become comfortable, just see that how IPv6 is used as far as making addresses, and you look at it, it's a little bit different. I mean, the concept's the same, assigning an address to each interface, but now it's just an IPv6 address, and their naming conventions a little bit different, but we'll get into that later. So right now, I want you more worried about, let's convert values. Again, watch this video and see if I do a good job. But basically, the concept is identical, except now I'm going to convert a decimal digit into the 8. You can take your decimal digit, you're going to convert it to an 8-bit binary string, and then you're going to divide that 8-bit binary strings into groups of 4. And you're going to always want to remember, always start from, when you're converting, you start from the left. And what you want to do is convert this into binary, group it, and as you can see here, We got 168. So this is 168. So it's the same decimal to binary conversion. Then what they do is say, because I have a hextet and it contains 4 bits, then I put 1010 in one of the hextets and 1000 in the second one. Then I convert this to a hex digit. You look at your table and say, okay, what value is that? That's the letter A. And then this in binary is the letter or the number 8. So 168 would convert to A8. Now, converting back from a hex to decimal, the same type of thing applies. First, you got D2. So what do I have? I got 2 binary numbers. I got the binary representation of D and the binary representation of the number 2. So when you make that conversion, you got D is 1101, number 2 is 0010. Of course, what do? I put those together to give me a grouping of an 8-bit grouping of 11010010. And then the same binary to decimal conversion, looking at each of the binary positions and say, okay, I've got 1 in the 128th, I got 1 in the 64th, I got 0 in 32, or 64, I got 1 in the 32, and I got 1 in the 2s. You add those numbers all together, gives you a decimal value of 210. So the concept's the same. It's just realizing that a hex digit has 6 more data values, A, B, C, D, and F, but the process is the same. If you say, okay, I'll let you run through this checklist, make sure you understand, and I hope that helps you understand a little bit of hex. The process is the same, except just remember you're only going to deal with, you're going to be converting a lot of 4-bit. When I see the number D, I'm going to convert that to a certain 4-bit combination. And if it was D2, like the example did, I'm going to make those conversions into those 4-bit numbers, combine those, and then do my binary to decimal conversion. So hopefully that helps. Take a look at the video they have here. Definitely do the practice, the module practice. Take the quiz here. It doesn't account for your grade, but it's just the more you do it, the better you're going to be at it. If you have any questions, let me know. Have a nice day. Bye-bye.